Well, dismantling that solenoid didn't really achieve that much. We were able to clean up the inside, but I'm still fairly suspicious that the solenoid is at fault, and so the reason being is that the starter motor won't stay engaged. I suspect that the fault probably lies in the solenoid coil, and so I need to really test that out a bit more. Problem is that to really do a proper test on the starter motor, I really need to attach the starter to a starter motor testing machine. That way I can apply a load onto the starter motor, and whilst at the same time having meters attached, I can see if one of the coils inside the solenoid is playing up. It's not so easy to do actually on the machine. I want to apply a constant load. Anyway, nevertheless, what I plan to do is to show some information about how the holding coil and the pulling coils operate in conjunction with each other to make the starter motor operate, and then probably what I'll do is put a new solenoid on the starter motor to test by substitution, which is really all I can do without a load tester for the actual starter. So let's look now at a couple of diagrams so I can illustrate how the solenoid actually operates in relation to the two coils inside it, and that way I can give a further explanation as to why I think it's still the solenoid that is causing the problems with the starter not staying engaged. When the starter button is pressed, both coils work together and draw about 38 amps between them, and this generates a strong magnetic field so that the armature can be moved against the pressure of the return spring, and movement of the armature causes the pinion gear to start to engage and eventually closes the bridge across the two terminals, terminal 30 and terminal C. The pulling coil draws the major current, that's about 30 amps, and the rest is pulled in by the holding coil. Once the armature is moved to its fullest extent and the two terminals are bridged by the contact plate, the armature will then get full power from the battery, and the starter motor will begin to turn the flywheel. At the same time, the pulling coil is disengaged because there is now the same positive supply at each end of the coil. Positive supply shown here and the positive supply here, so that stops the pulling coil from effectively working and takes 30 amps out of the equation, thus reducing the magnetic field considerably. The hold-in coil, which is using about 8 amps, produces sufficient magnetic field to hold the contact plate in the closed position for the duration that the starter button is pressed down. At the instant that the starter button is released, current then backflows up through the coil in the opposite direction, and this causes a reverse in the magnetic field. The effect of this is to collapse both magnetic fields quite rapidly because they oppose each other, and that allows for a rapid disengagement of the contact plate of the two terminals. The reason this is done is because if you had a relatively slow collapse of the magnetic field in the holding coil, the contact plate wouldn't leave the terminals cleanly and quickly, and that would generate a lot of arcing across these terminals and cause them to wear out in a relatively short period of time. So the reason why it's wired this way is to prolong the life of these contacts and therefore prolong the life of the starter motor. Of course, once the starter motor or the starter button is disengaged, the magnetic field disappears, and therefore the return spring can push the armature back to its resting position, and that disengages the pinion gear at the same time as disconnecting the starter from the battery. So, can you see now where I'm going with this? Well, I suspect there's a problem with the hold-on coil in the solenoid, because every time the starter is engaged, it immediately throws out again. The next step is to conduct some tests. First thing I'm going to do is measure the resistance of the two coils and see what we get there. I'm just going to measure the resistance of the two coils inside the solenoid. We've got one of the coils, there's two cables here on the solenoid that connect to the input terminal coming from the starter switch, and one of the coils goes to earth on the body of the starter solenoid, and the other coil goes to earth through the input cable into the starter and then earth through the starter motor armature. So first of all we'll measure the resistance to the body of the solenoid, and you can see there we've got a resistance of 1.8 ohms. Then we'll put the ohm meter through the other coil, same terminal on here because there's two wires attached to this terminal, and we'll put the ohm meter on the output there, and we've got a reading of 0.9 ohms there. So that's the resistance of the two coils. Now I'm going to set the coils up with a couple of ammeters and connect it to a battery and see what the current flow through is through in each coil, and we'll see what results we'll get there. So you can see we've got 3 meters here. The meter on the left, the yellow meter, is showing the battery voltage at the moment with no load across it. In a minute I'm going to connect up the holding coil and the pull-in coil for the starter motor. The gold coloured ammeter is going to show the holding coil current, and the round ammeter is going to show the pull-in coil current. So first I'll connect up the ammeter on the gold multimeter, and you can see now that the battery voltage has dropped to 12.3 and the current is about 8.5 amps. If I now connect up the round ammeter, you can see that the current on the round ammeter is about 30 amps, the voltage has dropped to about 10.5 volts, and the current on the gold multimeter is about 6.1. There you are, and I disconnected the holding coil last, and you can see that the holding coil then let go. Well, as you can see, we got reasonable results with those two tests, and it points to the fact that there's nothing wrong with the solenoid, but I'm still suspicious. The problem is that we haven't been able to test the starter motor under load, as I stated at the beginning of this video, and I think that the hold-on coil has broken inside and is making a connection, but every time you put a heavy load on it, the connection breaks, and that's when the hold-on coil fails. It's not unusual on circuits where that are faulty and a heavy current is being conducted for this type of issue to arise, and so therefore I'm still suspicious. And it comes back to the fact that, as I said right at the very beginning, the only way I'm really going to establish if it is the solenoid that's faulty is to substitute another solenoid onto the starter motor and then see what happens. Anyway, in the next video what we're going to do is carry on dismantling the motor itself and have a look inside that, see what sort of condition it's in. I don't think I'm going to find anything wrong from a visual sense, but nevertheless, just for the sake of seeing inside the motor and what kind of things you can clean up and check, we'll do that, and then put the motor back together and put a replacement solenoid on and see if that cures the issue. Okay.